Let's get right to it. Many of my videos simply regurgitate the same talking points. I'm actually doing that on purpose. Repeating the same things help repeat watchers understand the importance of what the real world looks like. Repeating the same thing helps new watchers learn what the real world looks like without having to go back over my older videos. Now, if you're serious about a career in machine learning or data engineering, then I'd spend some time watching my videos. My videos are the only truth out there on YouTube about real-world data roles. So, moving forward, I'm going to continue with similar videos. However, I'm also going to be adding some more educational ones. This video is about a gradient booster called XGBoost. Well, it's actually about all gradient boosters because they all use decision trees as a weak learner, but you get the idea. The decision tree is the foundation for all gradient boosters used in the real world today. If you didn't know that, and most don't, the gradient booster is the top model used in real-world machine learning. This is an excerpt from my course on XGBoost. Now, I had someone ask me, do companies really expect you to know how this works? These questions dumbfound me. If you're going to be using gradient boosters every day, then yeah, it's a good idea you understand how they work.
Gradient boosting is a powerful technique for building predictive models. Gradient boosting is about taking a model that by itself is a weak predictive model and combining that model with other models of the same type to produce a more accurate model. The idea is to compute a sequence of simple decision trees, where each successive tree is built for the prediction residuals of the preceding tree. In gradient boosting, the weak model is called a weak learner. The definition used when combining various machine learning models is called an ensemble. The weak learner in XGBoost is a decision tree. Therefore, we need to understand how the decision tree works before we can understand boosting. A decision tree is a graphical representation of all the possible solutions to a decision based on certain conditions. These trees can be viewed as a set of simple rules that contain simple clauses put together into a large equation. They are a series of if-then statements that segment your data into similar groups. The rules can be easily understood and can provide observations that are not always obvious with simple data inspection. It's called a decision tree because it starts with a single box or root, which then branches off into several solutions, just like a tree. While this definition is a little obtuse, several examples will help make this concept a little more lucid. Let's define a few core terms first. Let's start off with the tree. The start of the tree is called the root node. This node will split on the most important attribute in your dataset. After that initial split come the decision nodes. They are referred to as decision nodes because the split in the data has been made that has caused the tree to branch out into separate directions. Hence, an initial decision has been made on how to best split that data. The leaf node will often lead to the answer or the predicted value. Please keep in mind these examples are contrived and are only for instructional purposes. Let's take a look at one of the most famous datasets used in machine learning, the Titanic dataset. The Titanic was a British passenger liner that sank in the North Atlantic Ocean in the early morning hours of April 15th in 1912. There were approximately 2,200 people and crew aboard the ship, and more than 1,500 died, making it one of the most deadly commercial peacetime maritime disasters in modern history. One of the top reasons that the sinking resulted in such a great loss of life was that there weren't enough lifeboats. Although there was some element of luck involved in surviving the sinking, some groups were more likely to survive than others. Our picture on screen is the Titanic dataset. Our target variable, or that thing we want to predict, is called survived. Because the target variable is a 1 or a 0, this is a binary classification problem. Let's attempt to answer some questions based on our data. How would a decision tree be applied to this dataset? The very first thing the decision tree algorithm does is look for the attribute that is most important in the dataset. The phrase most important here is a little relative, and it's based on some mathematics behind the scene, that we're going to skip for now. The dataset has an attribute for gender titled sex. The algorithm has decided that the single most important attribute was the sex attribute. More specifically, is the passenger male or not? The root node is split into two groups, male and female. After the first split has been completed, the algorithm continues to analyze the other attributes in the dataset. The algorithm decided that the age of the passenger was the second most important attribute in the dataset. Specifically, is the passenger older than 9.5 years of age? That answer led to the split based on another attribute in the dataset, SIB-SP. The attribute SIB-SP simply means, did a passenger have siblings aboard at the time of the sinking? With each successive division, the members of the resulting sets become more and more like each other. Creating a tree involves deciding which features to choose and what conditions to use for splitting, along with knowing when to stop. Decision trees are helpful, not only because they are visual representations that help you visualize what you're thinking, but also because the design of a decision tree requires a well-documented thought process. Decision trees help formalize the brainstorming process so that we can identify more potential solutions.
Thanks for watching. Don't forget to like and subscribe. And of course, have a great day. We'll see you soon.